Welcome to JAMB Chemistry Past Question Review with Dr. Best.
Welcome to Past Question Review. This is a JAMB Chemistry Past Question Review, and we're going to looking at a topic, the periodicity of elements. This is the voice of Dr. Best exclusive tutorials. So I want you to follow me on this series because I'll be revealing, helping you to solve a whole lot of JAMB questions in almost all the topics that you do. Okay, now let's go with this question. This question says, an element with atomic number 12 is likely to have the same chemical properties as those in group. A says 1A, B says 2A, C says 3A, while D says group 4. Now, how do you know the group of an element? It's just as simple as writing either the electronic configuration of the element. Just writing the electronic configuration of elements is going to help you. Now, remember that elements are arranged like this in orbitals. You are going to see here electron. You are going to see here another electron. The second one will contain 8, 8, 8, 8, 8. So we are going to have 2 here. Now, this is an electron or an atom that contains 12 electrons. Now, this is what happens here. Now, it's going to be arranged this way: 2, 8, 2. Or you can as well use the other electronic configuration, the SPDF. So you're going to have 2s2, 1s2 first, 2s2, 2p6, which is 10 already, then 3s2. So at the end of the day, you are still going to end up with 2. Now, this just to let you know that this element belongs to group 2, and this one lets you know the element belongs to group 2. Now, all elements in the same group have the same chemical properties, so it's going to have same chemical properties with every other element in group 2. So the answer is B. Okay, here's question 2. Question 2 says the valence electron of cation are contained in A, 4s orbital, 3s orbital, 2s orbital, and 3p orbital. Now, just to write this, it's just for you to answer this, you just need to understand how to write electronic configuration. Now, cation contains is number 20 in your periodic table. So you are just going to write out an electronic configuration that is going to have 20 electrons. So you are going to have 1s2, 2s2, 2p6, 3s2. So we're already on the 3s2, 3p6, 4s2. Yeah, so you add this up: 4, 6, 10 plus 2, 12 plus 6, 18 plus 2 is a total of 20. So which is to tell you that the valence electron of calcium is contained in the 4s orbital, just like we see here. Now, some of us don't know how to write your electronic configuration. Now, let me show you how to write electronic configuration. Now, here you are going to have S, P, D, and F. S is going to contain just 2 electrons. P will contain 6. D is going to contain 10, while F is going to contain 14. Now, when writing, you are having S has only 1, so you are having 1s, then you are having 2s and 2p, you are having 3s, 3p, 3d, you are having 4s, 4p, 4d, and 4f. Now, every other one from 5 can actually contain up to f. So when writing it, it goes like this: 1s, it will now be 2s in this order. You are now going to have 2p before 3s. You are going to have 3p, 4s. You are going to have 3d, 4p. You are going to have 4d. Then down, anyone that is there, you are going to have 4d and the rest. They are going to have 4f and the rest. So this is how you arrange it. Now let's go to question 3. Question 3 says an element that has atomic number 38 belongs to period dash. Now, the same way we did this, so we are going to write out the electronic configuration of the element that has atomic number of 38. Follow this way that I asked you to write it. So you are going to have, let's have in mind we are getting to 38. So we are going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. After 4s we have 3d, 3d10, just like I told you. Then 4p6. Then you have you are going to have 5s, 5s2. So you are going to have 2 here, 4, 4, 10, 16, 18, 20, 30, 36, 32. So 38. So which means that it belongs to period 5. Now let me explain to you how to get the period. The last preface of your modern electronic configuration, that is the SPDF, the last preface is the period to which the element belongs to. Just like we have cation here, it means that this here ending at where's the electronic configuration of cation? Ending at 4s2, it means that cation belongs to period 4. So the last one is to get the period. Now let's proceed to number 4. Number 4 said elements in the same period of the periodic table show dash 1. Similarity in chemical properties. B. Progressively increase in atomic number. C. Progressive decrease in electronegativity. And D. Similarities in electronic structure. Now let's come here. Let me explain to you the electronic configuration. The periodic table. Now you have, these are the period, the horizontal lines. Then this is the group. So now this is the period. Now let's go back to the questions. The elements in the same period, option C says show similar chemical properties. They do not show similar chemical properties. It's only elements in the same group that shows similar chemical properties. So this option is out already. B. Progressive increase in atomic number. Now if you check from here, let's go back to this periodic table. You're going to be seeing that the atomic number increases as you go. Lithium is here. Beryllium has a higher atomic number than lithium. Lithium is number 3, beryllium is number 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. So which means that the correct option is this, increase in atomic number. Progressive decrease in electronegativity. This is wrong because when you go down the period from left to right, electronegativity increases. That is the reason why fluorine, which is here, is more electronegative than lithium, which is here. Similarities in electronic structure. They cannot have the same similarities in electronic structure because they are different elements. You get, right? Now let's go to question number 5. Now let's go to question 5. Question 5 says, which of the following physical properties decrease from left to right of the periodic table? Option A says atomic radius. I says ionization energy. 3 says electropositivity. While 4 says electronegativity. Now, for us to be able to answer this, now we have options. A says 1 and 2, B says 1, 2 and 4, C says 3 and 4, while D says 1 and 3. Now for us to answer this question, we really need to understand what these stuff means. Now let's begin with atomic radius. Now atomic radius is the distance. Okay, let me draw this and explain to you. Atomic radius is the distance between the center of the nucleus to the outermost electron. Now let me explain this to you. To the outermost electron. So this distance is considered your atomic radius, right? Now atomic radius is highest from left to right, which means is that metals has higher atomic radius. Now why do they have higher atomic radius? Now let me show you the electronic configuration of a metal, we are going to have 2 electrons here, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Now let's go again. Let's say, for example, this should be sodium. Here it's number 11. Now the distance between the center to here is far, so your atomic radius actually decreases down the period. Now I'm going to show you a picture. Okay, now look at this picture that explains this. Now you are seeing that atomic radius is bigger on the left compared to going to the right. So just understand that from left to right, your atomic radius decreases, which is to say that this one is already one of the answers that we're going to get, option 1. Now, ionization energy. What is ionization energy? Ionization energy simply means the energy that is required to remove an electron from an isolated atom. Now, let's say, for example, okay, let me still use this to explain ionization energy. Now, 1, 2, 1, 2, 1, 2, 1, 2, 2, 2, 1. This is for fluorine that has 9, which is 2 and 7. Now, let me draw that of hydrogen, right? Where you'll be having just 1 electron. Now, you will agree with me that the energy required to remove all these 7 electrons from fluorine is way higher than the energy required to remove only 1 electron from hydrogen. Remember, we are talking about the electrons in the atmosphere, and this atmosphere of hydrogen contains 1 electron, one out of fluorine contains 7 electrons. So what this means is that the metals from group 1 that is down the period, ionization energy increases, because that's the reason why metals, especially starting from alkaline earth metals, the group 1, they easily give out electrons to become ionized, to become a positive ion, while non-metals can easily gain electron because it's not so easy for them to give out. So ionization energy is going to decrease down the period, which means this option is wrong. Now, electropositivity. Remember that the metals are located on the left hand side, so going down, electropositivity is going to decrease. So this is another option. Now, electronegativity. Remember that from the left you have metals, to the right you have non-metals, which means that electronegativity is going to increase rather than decrease. So the 2 correct options are option 1 and option 3, which means D is the correct answer. Now let's look at this periodic table that I have here. Here is the group 1 alkali earth metals. This is the group 2 alkali metals. Here is the group 3. Here is the group 4. Here is the group 5, group 6, group 7, group 8. Now this one has 1 electron to give out, so the ionization energy to remove 1 from it is low compared to this one that has 2, 3, 4, 5, 6, 7, 8. So that's the reason why down the group electropositivity decreases, because they are becoming more electronegative, while electronegativity increases because they are becoming more electronegative. Now let's go to question 6. Question 6 says sodium atom undergoes ionization by A, sharing 1 electron, B, losing 1 electron, C, gaining 1 electron, D, gaining 1 proton, C, D, gaining 1 electron. Now remember what I explained to you. Sodium is number 11, so you are likely going to have 2, 8, 1, which means that, now what do we mean by an ion to undergo ionization? Ionization is the process of giving out or gaining or losing electron to become positively or negatively charged. Now when you are writing sodium ion, you are going to write +1, that is sodium plus, right? This means that sodium has already given out 1 electron. So when writing the number of protons here in sodium, the number of electrons here in sodium is going to be 10 instead of 8, because it has given out this one. So you are going to have 28. This is the difference between, now this one is your normal sodium meter, this one is your normal sodium ion. So what happened is that sodium gave out this electron. So the correct option is that it is losing an electron. It's not sharing. Now when we talk about sharing, we are talking about something like your covalent bond, when you have two chlorine ions, or two chlorine atoms, coming together to form Cl2 chlorine molecule. So this one is sharing. You get, right? So a molecule of chlorine can be formed through sharing, but this one, sodium is not going to gain a proton, it's not going to gain an electron, so it's true losing of electron. Now let's go to number 7. Number 7 says, now this is a reaction here, and A is an element which is converted to a ion. The above transformation requires dash: lattice energy, ionization energy, electron activity, sublimation energy. Now this one is already out of the equation. Ionization energy, just like I explained to you before, is the energy required for an element to give out an electron. What happened here is that this guy is not giving out an electron, just like I told you. What this means that this has moved from a neutral state to an ionic state, but having a minus here means it has gained an electron to become negatively charged. That's the reason for this charge. Now what is electron affinity, which is our next option? Electron activity is actually the energy that is required, or the energy emitted when an electron is added to a gaseous atom in its neutral state. Now this to show you that this atom is in its gaseous state. You get, right? So an electron was added to this atom to form an ion. So which means is that the energy that is needed here for this transformation to occur is electron affinity. Now let's go to number 8, the last question here. The question 8 says, the lower the difference in electronegativity between two elements, the dash. Now we have the higher the polarity of the interatomic bond, you have the lower the polarity of the interatomic bond, you have weaker the interatomic bond, and you have higher the possibility of forming a molecule. Okay, now let's talk about electronegativity difference. Now electronegativity difference is actually the difference between two elements. Now let's say, for example, you are having magnesium. Okay, let's say you are having calcium, which has the valency of 2+, and you are having chlorine, which has the valency of -1. So there is a large electronegativity difference in these two. Now in your reaction, element with higher electronegativity difference forms an ionic bond, while those with lesser electronegativity difference, just like two chlorine atoms having almost the same electronegativity difference, is going to form a covalent bond. Now what does this has to do with polarity? Now electronegativity difference is okay, let me say E difference is directly proportional to polarity, which means that when there is an increase, a high increase in electronegativity difference, where you are going to have a high polarity in the atomic bond. So this one says the lower the difference in electronegativity difference between two elements, the higher polarity in the atomic bond. No, the lower. Remember I said electronegativity difference is directly proportional to polarity. Weaker the interatomic bond. No. Higher the possibility of forming a molecule. No. So the correct answer is this. So here is a picture of the periodic table. So I want you to actually take note of all these things and ensure that you actually understand everything I'm saying. Now take note of electronegativity difference, positivity difference. Take note of all the groups in this periodic table, and as well take note of some of the things we have discussed: ionization energy, electron activity, and characteristics between period and groups. And also, what else do you need in periodic table? Electronic configuration. Having an understanding of this is actually a way of helping you to do in chemistry. See, chemistry is actually a product of periodic table. For you to do in chemistry, you should understand your element, because chemistry is more of the study of elements. So I hope this video was helpful. Follow up with this series, because I'm going to be doing more past question reviews every Saturday and be sending them to you. Thank you and God bless you. Don't forget to follow Exclusive Tutorials on all social media handles, and make sure you follow Dr. Best. Make sure you subscribe to this YouTube channel and turn on your notification button so that you always get notified when we upload videos. Thank you. We love you.